Hey, hi all. I hope you all are doing great. And today we'll solve problem 238, product of array except self of Leetcode. So the problem statement says, given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of num is guaranteed to fit in a 32-bit integer. You might write an algorithm that runs in a O(n) time and without using the division operation. So let's see the first example, which is 1, 2, 3, 4, right? So the problem says 0, 1, 2, 3. So the problem says whatever index you are standing at, okay, you have to find the product of all the number except that number in that index, right? So for example, if we are standing at index 0, we have to find product of all the numbers, that is from 1 to 3. Or let's say if you are standing at index 2, okay, you have to find the product of these two and this one except 3. Okay. So let's say we are standing at 0th index, the first index. What could be our answer? So 2 times 3 is 6, 6 times 4 is 24, right? So we are standing at 2 now. Let's delete this. So we are standing at 2 now. So 3 times 4 is 12, 12 times 1 is 12, right? Now we are standing at 3. So 2 times 1 is 2, 2 times 4 is 8, right? We are standing at 4. So 3 times 2 is 6, 6 times 1 is 6. So our answer is 24, 12, 8, 6, correct. So our understanding is correct, right? Now we have another example as -1, 1, 0, -3, 3. So you see we are standing at, let's say, -1. So 1 times 0 is 0 and 0 multiplied by anything will be 0. So it will be 0, okay, for this index. For first index 1, so this side on the left hand side we have -1, on the right hand side we have 0. Again, 0 multiplied by anything will be 0, so answer becomes 0. Now for zeros, that is second index, on the left hand side we have -1 times 1, that is -1, and on the right hand side we have -3 times 3 is -9, that is 9. So 9. And for 3 and 4, again you can follow up very easily. On the left hand side we have 0, so 0 multiplied by anything on the left and right hand side of this -3 will be 0, so 0, and same goes for this fourth index, 0, and this will be our answer, and that is same as the provided answer. Now the constraint is these, that our individual numbers would be ranging from -30 to 30. Okay, it also says the input generated is such that answer I is guaranteed to fit in the 32-bit integer. Okay, so that is great. And there is a follow-up. Okay, so before the follow-up, let's try to solve this the way we can possibly. Okay, so this says you must write an algorithm using the O(n) time and without using the division operator. So our ideal solution could be, we have calculated the product of all numbers, okay, from I0 to n-1, right? And we have stored in the product variable, and we could have divided that number on the particular index. So basically result I equals product by nums I, right? But considering that the nums I is not equal to 0, right, this could be one of our solution, but it says without using division operator. So we don't have to use the division operator anywhere in the code. So let's go with the brute force solution. Okay, so we have 1, 2, 3, 4, 0, 1, 2, 3. So standing at index 0, okay, this is our result. Okay, standing at 0, what we can do is we can multiply everything that start with I plus 1 till n-1, right? So basically 2 times 3, 3 times 4, that is 24. And for 1, the first index, what we can do is we can multiply everything to the right. Okay, so let's call prod right and prod left. Product on the right hand side, product on the left hand side, and the result on any index is equals to product right times product left, right? So basically, for any index 1, 2, 3, 4, 5, let's say we are standing at 3, we have to go all the way to the right and all the way to the left. So what are the elements that we are processing? N minus 1, right? Except the number, we are calculating the product of all the numbers to the left and to the right, right? And this is for all the index I, and we have to process all the index. So for every index, right, for every index I, we are doing this operation, I mean this times, right? And how many numbers we have, how many I we have, that is n, right? So this becomes n square 1, right, which is O of n square. So why I'm not proceeding with writing the code or explaining further, because this is self-explanatory, right? That for every index, we are just calculating the product to the right and product to the left, and we can arrive at the answer, right? But it says we have to write an algorithm that runs in the on time. So we have to find some better solution from here. Okay. Sometimes what happens is our solution is hidden in the brute force approach, and this is one of the problem that has that hint hidden in our brute force solution. So when you see 1, 2, 3, 4, and 5, okay, let's see this example. So when you are doing calculation for this number, okay, this second index, right, what you did, you calculated the left prod left as what, 1 times 2, correct? Now when you moved to 4, okay, and I mean for 3, of course you have calculated the right product also and left product also, but I'm just giving you a hint of what we actually take a hint from. So when you will be processing the 4th, that is the 3rd index, what product left will look like? Product left will look like 1 times 2 times what, 3. But you see, if let's say there would be n numbers here, m numbers, let's say, okay, so we have calculated the product of all m numbers, let's say prod of all m numbers times 1 times 2, and here we could have said product of all m numbers times 1 times 2 times 3, right? So basically we have to calculate all the numbers again just to add a single number on each iteration, isn't it? So see, we'll see clearly again, 1, 2, 3, 4, and 5. So let's say, so what is to the left of 1? Nothing. So let's keep it 1. So this is prod left that we are calculating, right? So we have 1 to the left of 1, right? Okay. Now what is to the left of 2? We can say 1. Okay. What is to the left of 3? 1 times 2, that is 2. Okay. What is to the left of 4? 1 times 2 times 3. But can we say this product is already been taken here? Okay, this product is already been taken here. So simply we can multiply these two numbers to get the next number. So we can multiply these two numbers to get the next number, that is 6. We can multiply these two numbers to get the next number as 24. By next number I mean the next product. Okay, that's great. And what is to the right of it? So what is to the right of 1? We can say 2 times 3 times 4 times 5. 2 times 3, 6. 6 times 4 is 24. 24 times 5 is 122. 120, sorry, 120. Now what is to the right of 2? Okay, what is to the right of 2? 3 times 4 times 5. So basically we have already calculated 2 times 3 times 4 times 5, and out of this product we are just we just want to get rid of this number, right? What we can do is simply divide the previous product, okay, from this number, but we have to not use any division operation. Okay, so in that case what we can do is, what we had done the operation for product left from the left hand side, for product right we can do this from the right hand. Okay, so basically what is to the right of 5? Nothing, so let's say 1. What is to the right of 4? So again, to get this number we have to multiply the next number, okay, in case of product right, okay, this number as in product right of next number times the next number, basically number present at the next index. So currently we are at index 0 1 2 3, right? So we want to calculate, so we want the product of this number and the product of product at this index. So basically 5 times 1 is 5. Now for 3, what we want is number at third index, the next index, and product at the next index. So 5 times 4 is 20. For 2, 3 times 20 is 60. For 1, that will be 120, right? And now we have the product left and product right at each index. So for 0th index we have the product left as 1, product right as 120. For index first we have the product left as 1, product right as 60. Okay, now what should we do? So for any index, okay, ni, we have product left I and we have product right I. We have to simply multiply this, right, to get the result. So basically result would be multiplication of all pairs of product left and right of each index. So for index 0, 1 times 120 is 120. For index 1, 1 times 60 is 60. For index 2, 2 times 20 is 40. For index 3, we have 6 times 5 is 30. We have for 5, 24 times 1 is 24. Is our calculation correct? So let's see for any index. So let's say for index 2, for basically 3, we have to find the product except 3. That will be 4 times 5 is 20. 20 times 2 is what? 40. 40 times 1 is 40. So we have 40. For index 3, 3 times 2 is 6, 6 times 1 is 6, 6 times 5 is 30. So we have 30, right? So let's try to code this up. So we have let product left, which is an array, okay, and it has a size which will be equal to nums length, okay, the same size as nums. And again we'll have the product right, which will be same length as nums. Now what we'll do, so we'll be calculating the product left from left and product right from the right end, right? So for let index equals 0, index be less than nums dot length and index plus plus, okay, prod left at any index, okay, equals to this number, basically product left of previous index times the number at the previous index. So prod left at any index, okay, will be equal to prod left at index minus 1 times nums at index minus 1, right? but this will throw error for the 0th index. So let's start index 0 with 1 and initialize product left as 0 as 1. You see, for index 0, for any index, the left product will be 1, right? And same goes for the product right. For any number, the right product, for the last number, the right product will be 1. Okay, so for the initial number, the product left will be 1. For last number, product right will be 1, right? So let's write it for let index be nums length minus 1 and minus 1 will be the last index, so minus 2. Index should be greater than equal to 0 and index minus minus, right? This is for the product right. Prod right at any index will be equal to prod right of next index times the nums at next index, right? So for product nums length minus 1, there is no initialization, so let's initialize for prod right nums dot length minus 1, and that will be 1, right? So we have product left, we have product right. So once we have the product left and right ready, we can return the result as nums dot map. This will be number and this will be index. And what we want to return as product left at index times product right at index, right? We want the product of all the numbers to the left, all the numbers to the right, and this will create a new array for every element, and that will be equivalent to the product left times the product right for that element, right? So let's try to run this out. This works, so let's try to submit. So it is accepted now, but there is a follow-up. You see, it says, can you solve the problem in O1 extra space complexity? The output array does not count as an extra space for the space complexity analysis. Okay, basically the output array that we will be creating, okay, here we are returning this output array dynamically. We are not creating any array. Basically we can create an resultant array, and whatever the operations we want to do in it, that is fine. But apart from this array, there should not be any extra array that should be created. So that operation, how we can do that? Let's see here. Okay, what you can say is product left. Okay, we are calculating 1, 1, 2, 6, 24. That is fine. Okay, now can we say for product right, we don't need actually an extra array. Why? So for 5, we know the left product is 24. Can we say if we know the right product to 5, we can simply multiply that to this number, right? And that will be our result. So let's try that out. Okay, so we have just calculated product left, okay, and we assume that we haven't declared any space for product right. Assume there is no memory allocated for product right. So we'll be doing the change in the product left array itself. So let's see, to the right of 5, what is the product? 1. Okay, now if we know we have the product left, I mean 24 here, it was initially 24, right? This is product left, right? This is same. We'll be doing the changes in place. So there is to the right, there is a product 1, okay, and to the left of 5 we have the product 24. So can we say 24 times 1 will be the answer here? So we'll write 24 here. Now let's come to 4. To the left of 4 we have 6, right? And to the right of 4 we have 5. Okay, just 5. So 5 times 6 is 30. Now coming to 3, to the left of 3 we have 2, and to the right of 3 there is a confusion now, because we have to calculate for all, because neither 4 has the information nor this number has the information, because this is 30 now. right? This is changed now. This is changed. This all are changed now. This is 24. This is 30. Now there is no way we know the right product for 3. So what we can do is, while iterating from the right to left, okay, we'll do one thing. We'll create a variable product right, and this will store all the products from the right. Okay, so we have 5. Okay, we'll not calculate here. We'll calculate when product right will be initialized as 1. So whatever to the right of 5, it will be fetched from product right. Not for 5, but for every index. Whatever the product right will be there, it will be just a variable and not a array, right? This was useless. So to the right, initial value is product right. Initial value of product right is 1. So 5 will say the product right is 1, product left is 24. This is not changed as of now, so 24 still is there. So 24 times product right is 24. Great. As we move left to 4, okay, this product right will be multiplied by the current number first before jumping to the previous index. And that's when the product right becomes what? 5, right? This becomes 5. Now 4 says I have, like, this is valid, 6 is valid, right, as of now. So it says to the left of me, that is 4. To the left of 4, we have a product of 6. To the right of me, we have a product right, that is 5. 6 times 5 is what? 30. Okay. Now before jumping to the previous index, what we'll do? We'll multiply the product right with the current number, that is 4 times 5 is 20. Now product right becomes 20. Now coming to 3. 3 says I have to the left of product to the left of me as 2, and the product right can be fetched from the current value of PR, that is 20. 20 times 2 is 40. These all are getting changed. Okay, these all are getting changed. So 2 becomes 40 now. This is changed now. Now again, so before jumping to the previous index, we'll multiply the current number with a product right? So 20 times 3, that becomes 60 now. Okay, so PR is 60 now. So coming to 2. So 2 says to the left of me, I have a product of 1. To the right, we have a product of 60. So 60 times 1 is 60. Now coming to 1. Before coming to 1, I'll multiply the current number 2 with the current PR, that is 60. So 60 times 2 is 120. So PR becomes 120. And 1 says to the left of me, I have a product of 1. To the right of me, I have a product of 120. So 120 times 1 is 120. And that was the result that we can obtain without using product right as array. We can use the product right as a variable itself. So 120, 60, 40, 30, and 24. So let's try to code this approach. So we'll not be using product right as an array. So let's delete this. Okay. And we'll be saying constant product right. And again, since this is not an array, we'll be deleting the index part of it. Okay. Product left 0 is 1. That is correct. So we'll delete this approach. Okay, now this product left. Okay, so this basically is the result which we'll be returning at the end. So let's keep the name as product left, but you can change the name to result. Okay, so we'll be returning product left as the result, because this array that we will be returning, that is not counted as an extra space. Right here it says the output array does not count as an extra space, so that's why I'm using the product. I'm reusing the product left array. Okay, now product left array, the first index, I mean the 0th index is initialized with 1. That is fine, right? Now what we will do is we'll say constant product right is 1, and when we will be iterating from right to left, okay, we'll be saying product left. So let's delete this line. So we'll be saying product left, or let's do one thing. Let's change the let's rename product left with result. I'll quickly rename this result, 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 result. Okay, result. Okay, I have renamed product left array as a result. So let's see, when we are going from left to right, that is iteration, that logic I haven't changed anything. Okay, now while coming from right to left, what we were doing is result at any index was equals to the product to the left, that is the value of the product left at that index. So basically result at that index itself times what? Times product to the right, and product to the right was fetched from product right variable. So product right variable is prod right. Okay, now we were doing one more thing. Okay, we were changing the index. Before that, we were multiplying the current number with the product right. So we'll multiply product right with the current number. So nums at index. Okay, that's fine. Now here on the previous approach, what we were doing is we were traversing from the second last index, right? So this time we'll be iterating from the last index, since we have the prod right as 1. Okay, so this will be the approach where we are not using any extra space apart from this one. I mean, from the problem statement it says this will not be counted as an extra space, although this is programmatically is an extra space, but okay. So let's try to run this. Okay, I'm so sorry. So since we are changing product right, so this should not be const, this should be let. Okay, let's try to run this. This is passed. Let's try to submit this. Okay, it is better than the previous solution, and this way we just solved our medium level problem of Leetcode. So thanks for staying till here, and see you in the next video.